Do what? Oh, I don't remember. Thank you. My pumpkin pie. All right, so this is going on page 67 when you're done. Or well, actually, not when you're done, like right now, because we're writing in your ISN. So this is probably where your 67 is. And then we are going to title this Graphing Rationals. Part 3. Graphing Rationals, Part 3, which is just going to consist of one example. So let me give you the equation. That will be f of x is equal to 2x squared plus 3x minus 9 over x squared plus 3. So when we do these, the first thing that we do is factor it. So go ahead and factor that. So in the numerator, you get 2x what? Minus 3 and x plus 3. Okay? And then what about the denominator? It does not factor. We did learn the other day that we actually can factor it, and I mean, we can force it down that road with imaginary numbers, but for the purposes we need for this, is it going to factor like in a useful way? Then no. Okay, so I can't factor that in a useful way, so it's x squared plus 3 in the denominator. All right, so then I go and find the pieces that I need to be able to graph. So start with the PD. And do I have any? No. Then R stands for what? Roots. So my roots are what? Negative 3 and 3/2. Then A stands for what? Asymptotes, specifically which ones? Vertical. All right, so do I have any of those? Where do they come from? The denominator. They're the zeros in my denominator, right? Can I make the denominator 0? Yeah, not with real numbers. Okay, let me put it that way. So yes, we can force that. But again, we are just talking real numbers because we're going to go and graph it. So then can I make it 0? No, which means I have no vertical asymptotes, so none there. Then the t squared stands for what? Togetherness or tangency. Do I have either one of those? No, because it's not just about having an exponent. It's about having multiplicity of factor, and that's not what I have here, so this is none. Then my E stands for what? Behavior, which would be my other asymptotes, right? Do I have a horizontal asymptote? Yes. 2. They're tied in degree, so the ratio of the coefficients is 2, so it's y equals 2. Then my y stands for what? Y-intercept, so it's really easy. You just cover up all it's multiplied out, cover up all the ones that have x's in it, so you get negative 9 over 3. There's negative 3. Okay. Then I need to look at my sign chart. So on here, I put my 0 and my vertical asymptotes. All I have are zeros here, so I get negative 3 and then 3/2. So when I do this, I've got substituted a negative 4. It's going to come up here, so that would give me negative 8 minus 3, so that's negative. Negative 4 in this one will give me a negative. Is it possible for me to substitute in a real number and get a negative out of the denominator? No, so it's going to be positive every time, so I can just ignore it, right? So I really just have negative and negative, which is 0. It's going to give me negative positive, which is a negative. If I substitute in like 2, then that's going to be positive positive. So it's like this. It's positive here, negative here, positive here. Okay. So that's what I have for all the stuff I need to find. Now you're going to take your little sticker here and we're going to put it long ways up here somewhere so that you have a little bit more room to write underneath. You can use the lines on your paper to help you straighten it, but you're not getting another one if you stick it down crooked, so just deal with it. Go ahead and place it on your paper so that the grid is a decent grid and it's not going to be all in freehand. Okay, make sure it's long ways. And then we need to put in an X and Y axis. So you have your ID for a straight edge. You do not have to, you don't have to count the grid or anything, just aim for the middle, and if you get close to the middle, it's good enough. Your ID is not quite big enough, but you can slide it along there. Okay, and then we are going to plot everything we can plot at this point. We do not have any point discontinuity, but I do have roots at -3 and one at 3/2, so that's like 1.5. I have no vertical asymptotes, no tangency or togetherness. I have an horizontal asymptote at y equals 2. I think it's hard for, it doesn't really show up well up there. You can tell where my asymptote is. And then we have a y-intercept at 0, -3. So far, how is this one different than the ones we've been doing? There's no vertical asymptotes. So when we first talked about domain, this said something like rationals often have characteristics that restrict the domain. It didn't say that they always have characteristics that restrict the domain, because all that restricts your domain in rationals are your point discontinuities and your vertical asymptotes. And on this one, we don't have either one. So our domain is all real numbers. It doesn't ask us for that at any point, but it's all real numbers. So all of my x's work. So I know from -infinity to -3, the graph is positive. So I'm above the x-axis. From -3 to 3/2, it's negative. So it's going to dip down here, and that makes sense because there's my y-intercept. And then from 3/2 to infinity, it's positive. What all of this stuff doesn't tell me is whether or not I cross that asymptote. Is it possible that I cross it? It is. So since it's already different than everything else, I need to check and see if maybe it does. So I'm going to take one of these two forms. It doesn't matter which one, but I'm most likely going to have to multiply back together anyway, so I'll take the original. And so I'm going to rewrite 2x squared plus 3x minus 9 over x squared plus 3. And remember, this is just a system of equations. I want to see where the function and that asymptote intersect, so where the rational line intersect. So I'm doing a system, they're both equal to y, I substitute, so I set this part here equal to what? 2. Not just because it's some random number, but because that's the equation of that line. It's y equals 2. So if that was a slant asymptote, then it might be all this is equal to x plus 2, or whatever the equation might be. All right, so then I just go in here and solve this. So in order to do this, I'm going to multiply both sides by that x squared plus 3. So this is going to give me 2x squared plus 3x minus 9 equals 2x squared plus 6. And then I solve this so I can subtract 2x squared from both sides. Everybody knows where that 6 came from, right? You get 3x equals what? 15. Good. 3x equals 15, and then x equals 5. So this right here, what does this tell me? When it crosses, that it does cross, and it crosses when x equals 5. So how many times is this function going to cross the asymptote? Just once, right? So I can go to x equals 5. 1, 2, 3, 4, 5. And when x equals 5, what's the y value? 2. That's the whole point of what we just did, right? So I've got that. So here's what I know. Since it only crosses once, and I'm coming from down here, this is going to go up above the asymptote, but it doesn't continue to increase like this. It's got to come back down because way out here when x is close to infinity, then the y value is getting closer and closer to 2. So although it goes above 2, it has to be concave down there. And then here, it's going to come up since it can't intersect it over here, it's just going to hug it from the bottom of it. So on either end, from negative infinity and infinity, we're getting closer and closer to 2. One's coming from the top and one's coming from the bottom. This is not a pointy thing. I don't get a V here. Just like with polynomials, things are curvy. So this is going to come down. It's possible that this is my minimum. I don't necessarily know that. So it's going to come down here. And then in order to go over, it's going to look like that. And then it comes back down. But not like, ooh, that's probably not that great. It needs to kind of swoosh back down that way. Mine kind of looks like it would go back down. Because this one actually comes up a little higher right here. And we can figure that out by finding a few points. But all we really need to know is that it's going to hug that asymptote on that side. And then this way, when it comes up, it's going to come up here from underneath. So it looks something like that. Okay. So if you know your acronym, you can find all these pieces that you need. On this one, the sign chart didn't help me so much because I don't have any asymptotes. It really helps more when I have asymptotes. And then maybe you need to check to see if it crosses the asymptote, or maybe every now and then you need to substitute something in to get another point to figure out what's going on with your graph. But even when they get weird, you'll be able to figure out what the graph is. Are we good? Any questions at all? Awesome. All right. Put your ISN away.